Hello, hi, Assalamualaikum, and very good day. I'm Dr. Zaitun from Civil Engineering Laboratory. I'm your lecturer for this test, influence lines. Influence lines is the diagram that represents the variation of either reaction, shear, moment, or deflection at a specific point. It is mostly used to analyze the structures that sustain moving loads such as bridge, and it can tell us at a glance where moving load should be placed on the structure so that it creates the greatest influence on the specific point of the structures. Well, to understand this test, theory is very important, and in this case, let us consider the simplest form of beam that is simply supported, where we can get influence line from this beam. So for this beam, we can get influence line for RA, RB, moment, and also shear force. Well, for the reaction, let's say reaction at A, the influence line can be obtained by assuming one unit weight applied at support A, that is 1 unit, pushed up at reaction A, and we got the deflection as shown in the second diagram, and then the deflection will be obtained. From this deflection, we can get the influence line of RA. Influence line diagram is actually mimic for the deflection of the beam, and then the maximum value is at A, that is 1, and then gradually reduce to 0 at support B, and it is linearly reduced. Let's look at an example on how we can get influence line of RA for this simple support beam AB, which is sustain point load P 10 kN at 2 meter away from support A, and we have understand that the influence line of RA, which is has the value of 1 unit at A and diminish linearly towards support B, and from here we can get the ordinate at any point on the influence line. By using the similar triangle, we can get the value of ordinate on the under the load that is Y1. It is simply by using the similar triangle, so we can get Y1 is equal to 4/6. Therefore, from the ordinate, so we can get the RA, the reaction at support A due to load P 10 kN is by multiplying the amount of load with the ordinate of influence line. That is the value of reaction at A. Well, this is another example to determine the influence line, but this time is due to the compound loads. Compound loads mean more than one load. In here we have two loads, 10 kN and 5 kN. Let's say we want to find the reaction at B due to two loads. Therefore, in this case, we need to draw first the influence line for RB. Again, by using the procedure as before, we must put 1 unit load at B, we push it up, and then radially reduce towards a support A, and then we obtain the ordinate of the influence line under each load. Therefore, the RB can be calculated by multiplying each load with its respective ordinate. This is another example for this simply supported beam, but this time it has overhanging over a support beam. Similar with the simply supported beam, we can get RA and also RB influence line. For example, if you want to get RA influence line, it's by applying 1 unit load to the support A, then we can get the value 1 unit positive on support A, and then it will reduce linearly 0 at support B, and then deflect at cantilever part. With Y or ordinate can be calculated by using the similar triangle as before. So for the lab test, we have a 3 objective, that is to determine the influence line of the support reaction of a bridge model. Second one, to identify the use of influence line for moving compound loads. And the third one, to compare the test results with the theoretical results. So we have so far learned how to determine the theoretical influence line. So we need to prove it by doing a lab test. The test not only to prove the theory of influence line, but also we want to determine whether the concept of influence line can be used for the compound load and the usage for the bridge model reaction. So this is the model that we bridge model that we will test in the lab. It consists of 6 support A, B, C, D, E, F, and if we look closely, it is actually a series of simple support that we have learned from the theory of that we can apply the theory of influence line as I mentioned before. As you can see in the free body diagram, it can be seen that A and B is actually simply supported with overhanging at C, and also EF overhanging at D. Therefore, for this span CD is actually a simply supported beam that is rests on the overhanging C and D. So in this test, we will find the influence line for RA, RB, RC, RD, RE, and RF, because we have 6 support here. But it is actually, the bridge is actually symmetry. Therefore we will find only RA, RB, and RC. But in the lab test, we will get the data for all the support. If you can see, the bridge has digital dial gauge for each support. Therefore, when we do the lab test, all the data from the dial gauge will be recorded. So now our task is to determine what is the influence line for RA, RB, and RC to RF. So as we have seen earlier on that RA is by putting the 1 unit load at support A. You can see this in the diagram, the 1 unit, and then it will deflect up 1 unit, and it will deflect linearly 0 to 0 at B, and then since C is overhanging, so it will also deflect, yeah, with YC, yeah. Then since beam CD is simple support, C will also deflect, yeah, following the deflection overhanging C, and then linearly reach 0 at support D. So the ordinate of the influence line can be obtained by using similar triangle. The ordinate can be seen at the last diagram, which using the similar triangle, and the table at the on your right is the calculation on how to get the ordinate of the influence line. The number of the beam 0, 1, 2, 3, 4, 5, 6 and until 11 is the point where we will put the load, yeah. Firstly, we will put the load on support A, and then we move the load to the point 1, point 2, 3 and so on. For influence line of RB, similarly we will apply 1 unit load at B, 1 unit at positive direction. So we have triangle, the 0 at the A. We draw the straight line to B, 1 unit load, and then since C is overhanging, it will also follow the deflection of AB, reach at maximum point at C, and then goes down because of CD is simple support, and C at D it will reduce to 0. So all ordinate in an influence line can be easily determined by using the similar triangle. And for the influence line of RC, again we will push the support C 1 unit weight up, and it is maximum at C, and the same procedure for the influence line for RD. We put 1 unit load at D, so the shape is similar with the RC. Influence line of RE is similar with influence line RB, while influence line of RF equal with influence line of RE. So now we have already found what is the influence line for each of the action of the bridge model, and then the next step is to determine the reaction due to moving load by using these influence lines. So in the test we have 2 tests. The first test is to using the single load, and the second test is to use compound load. So the most important thing is that for example, if you want to find the reaction at RA, therefore we need to find the ordinate for the respective load position as shown in the figure. Okay, now the first first test is that we will move the load from the load 2.5 kilogram from support A to point 1, 2, 3 until support F. Then we will draw the variation of the influence lines. So theoretically, as we have found earlier, the influence line is just like diagram shown at the bottom. But the test may give you different results. So from these influence lines, we can easily get the RA by multiplying the load with the ordinate where the load positions. For example, to determine the support A reaction, after we have the influence line ordinate for each position of load, then it is easier if we put in a table as shown in here. We have a position, we have a influence line ordinate, and then we find the reaction for each position of load, the RA for position of load in kilogram, and then we can change it to the Newton by multiplying with 9.81. So now if we have a compound load, so in the lab this is called test 2. So for the compound load, we have a set of load that is 5 kilo and 2.5 kilogram, which is 100 millimeter apart, and it will be moved from A to 1, 2, 3 and so on our bridge model. And then here we calculate theoretically what is the RA due to this compound load by using the concept of influence line. Again, like the previous single load, but this one is multiple load. It is similar. This is actually is the load multiplied by ordinate of influence line. Therefore, we have a new table as you can see here. So we have understand what is the influence line, how to construct influence lines, and also the usage of influence lines. So the next step is for you to watch the video for the laboratory test at the given link, and then you need to download the data for the test that is result obtained from the lab. There are two sets of data, so either one you can use it, and from this data you are needed to do three things. The first is construct both the theoretical and experimental influence line for RA, RB and RC, and compare it between the theoretical and the measurement. Second one is to construct the theoretical and experimental reaction RA, RB and RC, and then compare between them and determine the percentage of difference and find what is the reason for the disparity, and lastly discuss in less than 200 words the important influence line in the design. So in the lab report, you need to analyze and compare the theoretical with the measurements. That is, the first one is comparison between influence lines of RA, RB, and RC that we obtained earlier on for this bridge model, and then compare it with the theoretical with the experimental value. So this is example on how to construct the theoretical and experimental influence line diagram for reaction. For example, reaction A. So from the data sheet, since this is influence line, so the data sheet we required is either data sheet 1 or 2, but it must be obtained from test 1. Yeah. So here we will construct the influence line derived from the experimental. Therefore, we take RA reading at dial gauge A, yeah, when the load 2.5 kilogram position at A 1, 2, 3, and so on. Yeah, we abstract it. Thus, we create a table, a new table, by putting the load position, the distance, and the reading from the dial gauge at support A, and then we calculate the influence line due to reading gauge. The reading gauge here must be multiplied with the constant 14.8, yeah, and then divided by 2.5. Why we divide 2.5? It's because we want to get the unit weight, unit load. Yeah. So we have the unit load influence line now obtained from the dial gauge reading, and now we can compare with the RA influence line from the theory as shown in the table. For the comparison, it's better for you to for us to plot in a graph, in one graph, between the theoretical and experimental influence lines for RA. So you can see the difference and the disparity, and you need to calculate the disparity percentage and then give your reason why is it so. Okay, after we calculate or analyze the influence line obtained from the test, now we need to analyze what is the reaction at support A due to the load moving from support A to support F. So in theoretical, we use from the experimental value, we have a reading from the dial gauge. It must be multiplied with the constant 14.8 to get the force, and times with the 9.81 newtons to change from the kilogram to newton. So we have the reading support reaction at A from the experimental, and then we compared with the theoretical support reaction by using influence line, ordinate of influence line, times with the mass 2.5 times with the 9.81 to change it to newton. Again, we need to compare it, and it is better to perform in a graph. From the graph, we can see the disparity, and then you can calculate the disparity between them and find what is the reason for the disparity. And lastly, we analyze how the influence lines can be used to calculate the support reaction due to compound loads. Now this is example on how to use the influence line we obtained from the theoretical earlier on and compare with the experimental value. From the experimental value, we obtain the data from the test 2, that is from the compound load. Okay, so in the data sheet, it is from test 2. The reading were obtained from the dial gauge, from each dial gauge. So the example shown here is for the only for the RA, so you need to calculate the rest for RB and RC. So the RA obtained similar in the previous example. We need to take the reading from the dial gauge A, so it represents the value of RA. Okay, the reading gauge we put in the new table as shown here, the reading that dial gauge, and then this reading dial gauge is the value that need to be multiplied by the coefficient 14.8, and while for the theoretical value we obtain it from the reading of the influence lines times with the respective mass, that is 5 kg and 2.5 as shown in the table. So we have two values now from the theoretical and also from the experimental. And 9.81 Newton to get the reaction at support A. And it can be seen that experimental value give less value than the theoretical, and this disparity can be checked or can clearly be seen if we plot in a graph as shown here. Again, you must be able to draw a conclusion on why